learn how to solve absolute value equations.
Would you define absolute value?
The absolute value of a number is the distance the number is from zero on the number line. This notation represents the absolute value of x. The absolute value of positive 5 is 5 because it is 5 units from the origin. Likewise, the absolute value of negative 5 is also 5, as it is 5 units from the origin. Since distance is always a positive value, the absolute value of any number is always positive. The absolute value of 5 and the absolute value of negative 5 are both 5.
So how do I solve an absolute value equation?
Let's change the example into an algebraic equation involving an absolute value. Since both 5 and negative 5 have an absolute value of 5, write the equation as absolute value of x equals 5. Solving this gives two answers, x equals 5 or x equals negative 5. In this equation, absolute value of x equals negative 9. Since absolute value represents distance, and since distance must always be positive, this example has no solution. Now suppose the absolute value of x equals 0. Then x equals 0 is the only solution, since 0 and negative 0 are the same number. This is the rule for solving absolute value equations. If the absolute value of x equals a, when a is greater than 0, then x equals a or x equals negative a.
What about the absolute value of an expression?
Let's solve the equation absolute value of x minus 4 equals 5. First, remove the absolute value. To do that, set up two equations. The first equation is x minus 4 equals 5, while the other is x minus 4 equals negative 5, similar to the earlier example. Now solve each equation. X equals 9 or x equals negative 1. Looking at this graphically, start at 4 and move a distance of 5 in each direction. You end up at 9 or negative 1. The solutions to our absolute value equation.
Can absolute value problems get more complicated?
They sure can. This absolute value equation includes subtraction outside the absolute value. Use the following steps to solve the problem. First, isolate the absolute value term. Add 3 to both sides of the equation to get the absolute value of 2x plus 4 equals 8. Next, write two separate equations without absolute value notation. Solve both equations. Now check the two answers separately by substituting those values into the original equation. The final answer is x equals 2 or x equals negative 6. This next example has a negative 4 on the left side of the equation. Again, isolate the absolute value expression. Then, rewrite as two equations and solve. Check answers. And state the final answer.
Is it always necessary to check answers?
It's always a good idea to check your answers, but it's necessary for some absolute value equations. Use the same 5 steps to solve this equation. The solutions for the two separate equations are -4 and +4. Check your answers. The solution of -4 results in a false statement. 16 equals -8. However, +4 yields the true statement, 8 equals 8. -4 is discarded because it's an extraneous solution. It appeared during the process of solving, but is not a solution for the original problem. The final answer for this absolute value equation has only one value, x equals 4. In an absolute value equation, you must check answers to identify any extraneous solutions.